before we get to absolute value inequalities, it's important to talk about compound inequalities and how to solve them and write their solution in interval notation. So compound inequalities come in two different types, or and. And basically compound inequalities is just taking two or more inequalities and putting them together. So let's start with the or inequality. The or inequality looks like this, where you will have two different inequalities, usually pointing the opposite direction when you're looking at the graph, and you're saying my variable could be less than -2, or my answer could be 6. So answers like -5 or +20 would work because it fits into one of these inequalities. And the solution set, when you're looking at or inequalities, you're going to want to do the same thing. You're going to start at the smallest value. What's my smallest value here? It's -infinity, and we're using those parentheses again to indicate that you can't reach infinity. And then where does it stop for that first little section? It stops at -2. So the smallest value would be -2. It's not equal to, so let's use parentheses. Now let's look at the other interval. It starts at +6. I'm using a parenthesis to indicate that it's open at that point. And then it goes to +infinity. Now we have a symbol to indicate or, and it looks like U for union, because it could be either of these values. So basically we read this as my value could be between -infinity and -2, or my value could be between 6 and infinity. So one of those two values. Now the and inequality is the other compound inequality that we need to talk about. And it's saying that my solution has to fit both inequalities to work. So instead of writing two inequalities and writing an and in between them, how we write it is we write it with our variable in between the other two values. Notice that the two inequalities are both less than symbols. That will always be true. And you're saying here x is between -5 and +5. You could also read this as two inequalities. The first one, x is greater than or equal to -5. And the second one would be x is less than or equal to +5. Notice that the graph of these inequalities is shaded between those two values. So the solution set, where are they starting? They're starting at -5. Now in this example, it is included. There is an equal to line underneath the inequality. So we're going to use a bracket, and then it goes to +5. Again, it's included, so I'm going to use a bracket again. So that would be my solution set. It's a little nicer than my or inequality. It's a little cleaner. But each one has its pros and cons, right? So let's go ahead and solve a couple compound inequalities and then demonstrate again how to write their solution in interval notation. So here I have two inequalities. Here's my first one, here's my second, and I have an or written between them. So the awesome thing about this is we just solve it like we would normally solve inequalities. How am I going to solve this one? Well, I need to get rid of that 3, move the constant to the other side. 2x is greater than 12. Divide both sides by 2. X is greater than 6 would be the solution for the first one. Now I'm going to drop down that or because I want to make sure I'm keeping track that I need to do one of these or the other. It's not necessarily both. So I'm going to add 4 on the other side. -5x is greater than or equal to 5. I'm dividing both sides by -5 to get rid of the coefficient. Now you want to be careful here because what happened? We divided by a negative. What happens when we divide by a negative? We have to go ahead and flip that symbol. So it's now less than or equal to -1. So we're going to draw the wonderful handy-dandy number line 0, 1, 2, 6. I'm going to squeeze it in. I didn't really plan this out too well. Okay. Now I want to go ahead and what is my lower point? My lower point is x is less than or equal to -1. So let's start there. It doesn't matter which way you plot these. But it is equal to, so I'm going to shade in that circle, and I'm going to shade to the left because it's x is less than that value. Okay. And then my other one, x is greater than 6. Draw an open circle at 6, and I'm going to shade to the left, and I did not make enough room, so I'm going to create a new arrow. Boom. I don't shade that one in because it's not equal to. Now let's do the interval notation. Sometimes I just like to write negative infinity and positive infinity to keep track of it. So it's starting at negative infinity, and it's going to -1. I'm going to do a bracket there since we're including that value. U for union. And then my other one, I'm starting at 6. Now I'm not including 6, so I'm doing a parenthesis, and it's going to positive infinity, which of course I'm always doing a parenthesis on infinity. Hopefully you guys can read that. Looks like skin with green written on it. Kind of gross. Okay, anyways, so that's how you would graph and write interval notation for an OR inequality. Let's try the other one though. Let's try an AND. So the cool thing about an AND inequality is they've pushed 2 inequalities together, and you have 3 different sides. So here's the first sides, middle and right side. And essentially we want to get the x by itself in the middle. So we need to get rid of that 1 and that -4. So we do the same thing, but we need to make sure that what we're doing to the middle, we're actually doing to the other 2 sides as well. A little bit different. So we need to get rid of that constant first that's being added. So what I do to the middle, I've got to do to all 3 sides. So -4x is in the middle. 9 minus 1 is 8. -11 minus 1 is -12. Divide both sides by -4. Of course, I have to do it to all 3 sides this time. Now, notice that I did divide by a negative, so I have to flip all the signs. This becomes a +3. Now, when we're writing and inequalities, we like all the symbols to be less than symbols. Currently, they're all greater than symbols, right? Greater than, greater than. So we're going to just flip this inequality. Okay, mirror image, just flip it to the other side. So imagine just rotating it. -2 is less than or equal to x, less than 3. Flipped it on itself. This would be our inequality solution. However, we also need to graph it and write the beautiful interval notation. So let's do -3, -2. Okay, so -2 will be included because there's an equal to, so I'm going to shade that in. 3 will not be included because it's not equal to, and then we just shade in between those 2 values. Boom. And it's shaded. Now, we're going to go ahead and write the interval notation. So where does it start? It starts at -2, so I'm going to draw a bracket at -2, and it goes to +3. Notice it does not include +3, so we're going to do parentheses around that. So we've drawn the interval notation and graphed it. We're becoming inequality graphing experts, aren't we? So keep practicing solving the inequalities and let me know if you have any other questions.